Have you ever stopped to wonder if everything we know about the universe is wrong? What if the universe isn't the vast, infinite expanse we've always imagined, but something much smaller, more compact, and far more mysterious? In today's video, we're diving into a mind-bending question that could change everything we think we know. What if the universe is smaller than we think? We'll explore the deepest corners of quantum physics, challenge our understanding of space-time, and reveal theories that suggest our cosmic scale might be all wrong. Could it be that the universe, with all its galaxies and stars, is just a tiny bubble in a much larger reality? Stick around, because what you'll learn today might just change the way you see the world, literally. And before we get started, think about this. If the universe is smaller, what does that mean for our place in it? Let's find out together. When we think of the universe, we often imagine an incomprehensibly vast expanse, measured in light years that stretch across billions of galaxies. Scientists, armed with the latest telescopes like the Hubble Space Telescope, have spent decades piecing together this cosmic puzzle. They rely on cosmic background radiation, the afterglow of the Big Bang, to map the observable universe. This radiation acts like a distant echo, guiding us to the farthest reaches of space-time. But here's the kicker. What if all these measurements, as advanced as they are, aren't telling the full story? What if there's more, or perhaps less than meets the eye? It's fascinating to consider that all these measurements, the light years, the cosmic radiation, give us a picture of the universe on a colossal scale. But let's pause for a moment and think about it. What if this entire cosmic scale is just a fraction of the true nature of the universe? Imagine, for example, you're looking through a frosted glass window. You see shapes, lights, and shadows, but you don't get the complete picture. Could it be that our understanding of the universe is similar, that we're only seeing a small, distorted version of the grand reality? The tools we use, while revolutionary, might be limited in their capacity to reveal the true nature of the cosmos. So, if the universe is indeed smaller, what does that mean for everything we know? Our current models of space-time, quantum physics, and even the Planck length, the smallest dimension we can theoretically measure, could all be fundamentally flawed. It's like trying to solve a puzzle with missing pieces. We're confident in the picture we've created, but we can't be sure it's complete. And this opens up a tantalizing possibility. Perhaps, just perhaps, the universe isn't as big as we think. But what if it's smaller? And what does that mean for the very fabric of reality? Let's dive deeper into this mind-bending concept. Now, imagine for a moment that the universe isn't as vast as we've been led to believe. What if space-time, that intricate web connecting every star and galaxy, is far more compact than we can perceive? This idea isn't just science fiction. It's rooted in theoretical physics and concepts like the holographic principle. According to this theory, the universe could be a two-dimensional surface projecting a three-dimensional reality, meaning the universe's actual size could be much smaller than what we observe. Think of it as looking at a shadow on the wall, where the shadow appears larger than the object casting it. Could our universe be a grand illusion, scaled up in our minds but far smaller in its true form? This possibility fundamentally challenges our understanding of distance, time, and space itself. Imagine planning a road trip based on a map that's not to scale. You'd end up either vastly underestimating or overestimating the journey. Similarly, if the universe is smaller, our concepts of space travel, cosmic distances, and even the passage of time could be entirely different. For instance, light from distant stars might not have traveled across millions of light years, but rather across a much shorter, more condensed distance. This could mean that what we perceive as the far reaches of the cosmos might be closer than we think, packed tightly in a much smaller universe. But here's where things get even more intriguing. What if the universe we see is just a projection, a limited view of something much smaller yet infinitely more complex? Imagine standing in a room full of mirrors, each reflection giving the illusion of endless space. Yet, the actual room is much smaller than it appears. This projection theory suggests that the vastness we observe could be a mere reflection, a scaled-up version of a universe that's more compact. If that's the case, then our entire perspective on reality, on what it means to exist in this universe, could be due for a major rewrite. But what evidence do we have to support this mind-boggling idea? Diving into the realm of quantum physics and theoretical frameworks, we begin to uncover evidence that might support the idea of a smaller universe. One such theory is string theory, which posits that the fundamental particles we observe are not point-like dots but tiny, vibrating strings. These strings exist in multiple dimensions, some of which could be compactified, curled up so tightly that they're nearly impossible to detect. If these extra dimensions exist on a microscopic universe scale, it's possible that the entire structure of our universe is far smaller and more compact than we perceive. This opens up a Pandora's box of possibilities about the true nature of space-time. Consider, for instance, the cosmic microwave background, this faint radiation left over from the Big Bang. It's often used as a map of the early universe, but some anomalies in its patterns suggest that we might not be seeing the whole picture. Recent studies have hinted at the possibility that these anomalies could be signs of a smaller, more finite universe, rather than the infinite expanse we've always imagined. It's like finding a hidden message in the static, something that doesn't quite fit with our current models but could point to a deeper, more complex reality. Moreover, quantum mechanics introduces another layer of complexity to this discussion. The principles of quantum entanglement, where particles remain interconnected regardless of distance, suggest that space might be more interconnected and condensed than it seems. This phenomenon challenges our traditional understanding of distance and could imply that the universe operates on a scale much smaller than we currently believe. Imagine the universe as a tightly woven fabric, where every point is intimately connected to every other, shrinking our sense of vast distances. If that's the case, then perhaps our universe is just a tiny bubble within a much larger, more complex structure. But how would this change our understanding of reality? If the universe is indeed smaller than we think, this revelation would shake the very foundations of our understanding of reality. Imagine waking up one day to find that the world around you is not as large or as spacious as you believed. Everything from the laws of physics to the nature of space-time would need to be reevaluated. The concept of distance, for instance, might no longer hold the same meaning. What we once thought were vast stretches of space between galaxies could be far more condensed, leading to a rethinking of how we perceive movement and time in the cosmos. This realization could alter our approach to space exploration, possibly making it more accessible and less daunting. On a more philosophical level, a smaller universe could profoundly affect our understanding of existence itself. If the universe is not as vast as we believed, then what does that say about our place within it? The grandeur of the cosmos has always inspired a sense of awe and insignificance, but a more compact universe might bring everything closer to home, literally and figuratively. We might start to view ourselves not as tiny specks in an endless void, but as integral parts of a much more interconnected and intimate cosmic fabric. This shift in perspective could lead to a new era of thought, where the boundaries between the macrocosm and the microcosm blur, and where the universe's smallest dimension holds as much wonder as its largest. But let's not forget the practical implications of this revelation. Technology, for example, could undergo radical advancements. If the universe is smaller and more interconnected, harnessing the power of space-time could lead to breakthroughs in energy, communication, and transportation. Imagine being able to tap into the fundamental constants of the universe in ways we never thought possible, using them to solve problems we once considered insurmountable. This could change everything, from the way we power our cities to how we communicate across the globe. But with all these possibilities on the horizon, we must ask ourselves, have we truly grasped the scale of our own reality, or is there more to discover? Despite all our advancements in science and technology, the true size of the universe remains one of the greatest mysteries of our time. We've explored the cosmos with telescopes that peer into the farthest reaches of space, yet there's still so much we don't know. Every discovery seems to open up a new set of questions, each more complex than the last. What if the universe is smaller? What if our understanding of space-time, from the largest galaxies to the smallest dimensions, is fundamentally flawed? These are the kinds of questions that keep scientists and philosophers alike pondering the nature of reality. Even with our best efforts, the universe may never fully reveal its secrets to us. It's as if we're looking at an intricate piece of art. Each detail we uncover only adds to the complexity of the whole. The concept of a smaller universe challenges everything we thought we knew about cosmic scale, quantum physics, and the limits of the universe. It suggests that we might be living in a universe that is more finite, more intricate, and more connected than we ever imagined. And while this idea might seem daunting, it also holds a certain beauty. After all, the pursuit of knowledge is not about finding all the answers, but about constantly seeking new questions. So, as we continue to explore the cosmos, we must remain humble in the face of the unknown. The universe, in all its mystery, may never give up all its secrets, but that's what makes it so fascinating. It invites us to keep searching, to keep questioning, and to never settle for easy answers. Because the true nature of the universe, whether it's smaller, larger, or something else entirely, is a puzzle we may never fully solve. But isn't that what makes the journey worth taking? And speaking of mysteries, have you ever wondered what role dark matter might play in this cosmic puzzle? As we wrap up this exploration of a possibly smaller universe, it's time to think about the bigger picture, or should we say, the smaller one. If the universe is indeed more compact than we've always believed, how does that change your view of reality? What does it mean for your daily life, your dreams, and your understanding of the cosmos? Imagine the possibilities if space-time is more connected, if distances are shorter, and if everything you thought you knew is just a fraction of the truth. So, what's your next step? How will this knowledge influence your journey through life? I encourage you to keep questioning, keep exploring, and never stop seeking the answers to the universe's greatest mysteries. If you found this video insightful, be sure to like, share it with others, and subscribe to our channel. Turn on those notifications so you won't miss our next deep dive into the unknown. And before you go, here's a thought to ponder. Could dark matter hold the key to stopping black holes from dying? If you're curious, check out our previous video where we tackle this cosmic conundrum. Until next time, keep looking up and keep wondering.